Hello guys, in this video let's look at the power of product and quotient law of exponent. So first let's look at this power of product law, which says that AB whole raised to R is equals to A raised to R times B raised to R. Suppose if you are asked to calculate 2 raised to 5 times 5 raised to 5, then you might be calculating this in a longer way, like you might be first calculating 2 raised to 5, which is 2 multiplied for 5 times, which is equals to 32. And next you might be calculating this one, that is 5 raised to 5, which is 5 multiplied for 5 times, and which is equals to 3125. And finally you might be multiplying 32, that is 2 raised to 5 times 5 raised to 5, that is 3125, which is equals to 100,000. But this is where this law is very helpful. So with the help of this law, I can write this 2 raised to 5 times 5 raised to 5 as I can simply multiply the base, that is 2 times 5, and I can do whole raised to this exponent 5. So which means 2 times 5 means 10, and then we have this exponent, that is 5, and 10 raised to 5 means 100,000. So obviously this calculation is much easier and faster than this lengthy one. If you are asked to calculate 8 raised to 4 times 10 raised to 4, using this law, this will be equals to multiply the base, that is 8 times 10, and this will be whole raised to 4, which is equals to 8 times 10 means 80 raised to 4. Using this law, you can write x raised to 5 times y raised to 5 as x times y whole raised to 5. Or in other way, if we have x times y whole raised to 7, I can write this as x raised to 7 times y raised to 7. Now let's quickly look at this power of quotient law of exponent, which says a divided by b whole raised to r can be written as a raised to r divided by b raised to r. Suppose if you are given 10 raised to 5 divided by 5 raised to 5, you might be doing this in a longer way, like 10 raised to 5 means 10 multiplied for 5 times, and 5 raised to 5 means 5 multiplied for 5 times. Now 5 times 1 is 5, 5 times 2 is 10. Similarly, 5 1 is 5, 5 2 is 10. 2 times 2 times 2 times 2 times 2 means 32. But using this law, you can write it in a much simpler way, like 10 raised to 5 divided by 5 raised to 5. I can write it as 10 divided by 5 whole raised to the exponent 5. And 10 divided by 5 means 2, which is 2 raised to 5. And 2 raised to 5 is simply 32. So this way is much easier and faster than this lengthy way. So this is exactly where this law becomes very handy. If I have 20 raised to 10 divided by 2 raised to 10, using this law, I can write it as 20 divided by 2 and whole raised to this exponent 10. 20 divided by 2 means 10, and then the exponent here is 10. You can leave this in exponent form because the exponent is 10. So if you want to write this in a standard form, this will be a huge number, which is 1 followed by 10 zeros. So better you leave this in exponential form. If I have x raised to 5 divided by y raised to 5, I can write this as x divided by y whole raised to 5. Or if I have a divided by b whole raised to 20, I can write it as a raised to 20 divided by b raised to 20. So I can go it either way. I can go from here to here and come from here to here. Now let's look at this problem, which says which of the following expression is greater in each. So you can determine this one without having calculator. Let's do support 1. We have 6 raised to 4 or 3 raised to 5 times 2 raised to 5. This one right here, I can write it as 3 times 2, multiply the base, and then raise to the same exponent, that is 5. 3 times 2 means 6, 6 raised to 5. So obviously 6 raised to 5 is greater than 6 raised to 4. So which means this expression is greater than this one. Let's look at subpart 2, which says 5 raised to 4 or 30 raised to 3 divided by 6 raised to 3. I can write this as 30 divided by 6 and then whole raised to the exponent 3. And this 30 divided by 6 means 5, and then we have the exponent of 3. So obviously 5 raised to 4 is greater than 5 raised to 3, which means this expression right here is greater than this one. Let's solve part 3, which says 3 raised to 12 or 9 raised to 7. So for this, I want to make the same base. So I can write this 9 as 3 times 3, which is 3 square. So this one I can write it as 3 square, that is 9, and then I have exponent of 7. Now this one I can write as 3 raised to, I can multiply this 2 exponent, that is 2 times 7, which is equals to 3 raised to 2 times 7 means 14. So obviously 3 raised to 14 is greater than 3 raised to 12. So which means this expression right here is greater than this one. Now let's look at this another problem which says order this from least to greatest. And for this as well, we don't need any calculator. We can use different laws of exponent to determine which one is greater. So the first thing first, I want to make the same base. So I want to make all the bases as 2. So this one I can write it as 2 raised to, I can multiply this 2 exponent 4 times 4, that becomes 16. And this one I can write 8 as 2 times 2 times 2, which is 2 raised to 3. So it becomes 2 raised to 3 whole raised to 5. And this one I can write this 4 as 2 times 2, which is 2 raised to 2. So this becomes 2 raised to 2 whole raised to 3 whole raised to 3. And then this one I can write the same base, that is 2, and multiply this 2 exponent, that is 7 times 2 means 14. And then for this one, negative number raised to positive exponent means it will be a positive quantity. So this negative 2 raised to 8 is as same as 2 raised to 8. And then this one I'm going to leave it as same, so which is negative 2 raised to 30. Now let's do some more simplification. This one will remain as it is, 2 raised to 16. And this one will be 2 raised to 3 times 5 means 15. And this one will be 2 raised to 2 times 3 times 3 means 18. And this one will remain as it is, 2 raised to 14. And this one as well, same as it is, so 2 raised to 8. And then this as well, it will be same, that is negative 2 raised to 30. Now since all the base are same, that is 2, so I can compare the exponent. Now you look at this number is going to be negative because we have negative sign in the front. So this number will be least among all the numbers. So 2 raised to 30, that is the smallest one. And now all these other numbers are going to be positive. Since all the base are same, that is 2, 2, 2. And so let's look at the exponent, which means 8 is smallest among all. So next it will come 2 raised to 8. Then it will come 14, that is 2 raised to 14. Then it comes 15, 2 raised to 15. Then it comes 16, that is 2 raised to 16. Then it comes 2 raised to 18. So the smallest number is this one, that is negative 2 raised to 30. Then the next smallest is this one, negative 2 whole raised to 8. Then the next smallest, that is 2 raised to 14, is this one, that is 2 raised to 7 whole raised to 2. And next we have 2 raised to 15. 2 raised to 15 is this one, that is 8 raised to 5. And next we have 2 raised to 16. 2 raised to 16 means this one, that is 2 raised to 4 whole raised to 4. And then the greatest among all this number is this one, that is 4 raised to 3 whole raised to 3. So we have arranged these numbers from least to greatest. Now let's look at this last problem, which is asking us to find this value of n. So this one I can write it as 3 raised to 2 divided by 5 raised to 2. So I can distribute this exponent in the denominator as well as numerator. Times, and I can write this 25 as 5 raised to 2, which is equals to 3n. Now 5 raised to 2 and 5 raised to 2 get cancelled out, which leaves us 3 raised to 2 equals 3 raised to n on the other side. Since the base are same, therefore this exponent on the two side must also be same. So n should be equals to 2 on this case. So guys, I hope this video is helpful and thank you for watching.